Hello everyone. Here I have seen several videos and several lectures of electrostatics explaining the Coulomb's forces and electric field. While from MIT Open courseware, even in India, IIT, in NPTEL videos and many more. But I want to explain here something. What is an electric charge? I haven't get anywhere the perfect explanation of electric charge. Each and every lecture has started just supposing the charge over an electron is negative, charge over a proton is positive. But this is the first question in electrostatics. What is an electric charge? How will you explain it? We need some definition type analysis, and we need some analysis that is corresponding to some mechanical properties so that we can relate electric charge to our daily life. Like this, in mechanics, we have studied a lot about masses and its behavior in the physical domain, and we are quite familiar with the mass. But here, in electrostatic world, whatever the charged particles, we cannot see it, or we cannot physically feel it. So, to give a physical feeling of electric charge for beginners, especially in electrostatics, I'm going to explain electric charge. What is an electric charge? I'm not creating its definition, I'm not creating an electric charge, and I'm not giving anything different. Just I'm analyzing it physically, how we feel, how we have to start in electrostatic, or what is an electric charge. Okay, see, I have drawn these two figures beginning. One figure is, you all are quite familiar with this figure. The figure contains a huge and massive object, that is sun, having mass m at the center of our solar system, and the planet, suppose let it Earth or any other planet, is revolving around this sun, having mass smaller. Corresponding to this figure in electrostatic, I have drawn another figure. But this is our atom. This is our atom. Is it visible?
Yeah, it's visible.
Atom. And at the center of atom, there's a nucleus which contains some of the positive charges. And around the nucleus, inside the atom, there are some negatively charged particles which is revolving through it. You can ask me that you also saying charge, you haven't explained it. I'm going to explain it. That what is an electric charge exactly? We're familiar with these two figures, and now I need some more space, so I'll have to erase some part of this figure. See. Here, everyone is familiar here, and everyone knows that if something is if something is revolving around the body, another object to any other axis, it is under the influence of centripetal force. So this mass is under the influence of centripetal force. And who is providing centripetal force here? Everyone knows it. The centripetal force here is provided by the gravitational pull, and that pull is this. That pull is here in this figure. This m is revolving around this huge mass, or point axis passing to the center of this mass, and this m is under the influence of centripetal force, and that force is provided here by the gravitational force or gravitational pull. That is Fg is equals to Z m by r square. R is the distance from here to here, that distance. And this force is attractive, so the particle is revolving into this orbit. You're quite familiar here because it's mass here. Means mass is an intrinsic property of any matter that produces the gravitational pull with another mass. Another property of mass is F is equals to ma. The mass here and here, both are the same mass. Here mass is explained over gravitational mass, and here mass is explained by inertial mass. But the mass is same here. Means, suppose a body has mass m and it is under the influence of a force, then it must have an acceleration. That acceleration determines the direction of that force. we have to do the same analysis to feel the physical feeling of charge, how it begins in electrostatic. Now I'm going on that figure. See, this is the basic model of an atom. The model is not quite perfect right now because right now quantum physics designs the model of atom. But this is the first model which is considered to be true for atom. And this model contains a nucleus at its center. Actually, the nucleus is not so big, it is very, very small. It's very, very small. This is nucleus at the center of the atom, and there's an other particle which is very, very smaller than this nucleus in terms of mass, which is revolving around this nucleus inside this. Again, here you find the feeling of revolution, and once you find the feeling of revolution of anything around an object, around an axis, you think of something which is centripetal force here also. And once I think about centripetal force, my attention goes to the masses, the mass of electron and the mass of nucleus. And as calculated value by gravitational pull, mass of nucleus and mass of this electron by the distance, that is the r. So initially scientists thought that the pull, gravitational pull here provides the centripetal force, but actually the force is too short than the centripetal force required here, and that's why the theory has been discouraged. What happened?
Someone's call is coming. Don't wait, let me dismiss it.
Dismiss.
Or should I ask him?
No, dismiss it. After a few minutes we'll take a call. So the reason of centripetal force here and orbiting electron around the nucleus is not gravitational pull. So they thought about something different, and by experiments they determined that is this is a new formula which is quite familiar with the gravitational pull. But this is the reason of centripetal force here over the electron while revolving around the nucleus. This is an electric force, so you call it Coulomb's force, which is used in electrostatics. It's an electromagnetic force. Q is an intrinsic property of electron. This property is completely different to that property, that is mass. So this new intrinsic property of electron is different than the mass. So it's also an intrinsic property, but it is different than the mass. And a new intrinsic property of electron apart mass. Similarly, Q is the intrinsic property of this nucleus apart from its mass. Is it visible from there?
Yes, the whole board is
The new intrinsic property of nucleus apart from its mass. So from here we can think about that. Here mass is not responsible to provide centripetal pull. Here there's an intrinsic property which is only present in electron and proton, actually in nucleus, which is responsible for centripetal pull here. Means the centripetal force provided for electron to revolve around this orbit is not due to the mass but due to the charge. Due to an intrinsic property, that intrinsic property is termed as charge. So you can say me that I'm not able to understand what is this intrinsic property. Let me explain it in some detail. So, apart mass, there is an intrinsic property to the elementary particles, especially electron and nucleus, or inside nucleus there are protons and neutrons. So, apart from mass, there is an intrinsic property to electron and nucleus that is responsible for the centripetal pull here. That property is considered as electric charge. But let me explain it in some more detail. This and the centripetal pull here looks like this 1/4 by epsilon naught.
You already wrote it.
Q by r square. And comparing this formula to the formula in mechanics, that is F equals to ma, I'm comparing two intrinsic properties, the charge to its mass, to give you a physical feeling of what is actually charge. Because in electrostatics, we don't see what is charge. In mechanics, you can feel masses by holding anything in our hands, so throwing it, calculating its energy, finding its momentum, and finding forces over it. But in electrostatics, what is charge? What do we do with the charge? How the charges feel force to each other, and how charge exert potential anywhere. All these things have no physical feeling. So I'm analyzing charge relating to mass, a physical feeling. This. And do some simplification here. 1/4 pi epsilon naught. Q by r square, taking Q outside. Now we have a feeling. This force looks like this. Compare this formula to F equals to ma. Let me erase this. Compare this formula to F equals to ma. Here you have an intrinsic property of any matter, and while applying force over that matter, you have an acceleration inside it. Here, this is another intrinsic property of the matter or the elementary particles. Applying force over it, you have this term. And we put a special name this compared to this. That is Q into E, electric field, where E is equals to Q by r square, electric field, at Q. So what have we noticed here? The formula is quite familiar with this. Means one intrinsic property under the experience of force gives you acceleration, another intrinsic property under the experience of force gives you electric field. So now you have a physical meaning, you have a physical feeling of what is charge. This. And F is equals to QE, F equals to MA. So you have a physical feeling. Similarly, just as if we have a mass and it experiences force, so after experiencing force, it gives you an acceleration that determines the direction of applied force or the resultant force over that body. Similarly, charge is an intrinsic property, and under the influence of electrostatic force, the electrostatic force is completely different than this gravitational force. So whenever you have an electrostatic force on any body, or any matter, or any particle, it has an other intrinsic property, that is Q, which gives you the direction of force. Understood that? The same reaction here and here. In one case, if you have a particle where you are giving the gravitational force, then you have an acceleration that determines the direction of the force. In another case, if you are exerting if a particle is experiencing electric force or electrostatic force that is completely different than this gravitational force, then it has a effect. That effect is this electric field that determines the direction of force. Understood? This difference is due to intrinsic property, because these intrinsic properties are different to each other. M and Q are different to each other. But you can analyze these two things. One thing is that comparing the force, electrostatic Coulomb's force to gravitational force, and comparing this formula to this formula, we have a physical feeling of charge. Understood these two things? Now the third one is that mass is an intrinsic property. To what level? The question is this: suppose I have this mass, and I distribute it under 100 terms or more smaller formats. So suppose I have the mass of this smaller part is M. If I distribute this parts more smaller, that is, suppose dm. Similarly, as smaller part we have, as smaller we have mass, and finally theoretically we reach up to nothing. From molecules to atom to nucleus and electrons, inside electron there are quarks, inside quark there are many more, and finally whatever we know yet, that is the, what is the God particle, that is boson. That is not boson. God particle, that is boson, means it provides mass to everything. Means you can say that mass is an intrinsic property of each and every type of element or every type of part inside the element, which begins from boson. Understood? But in terms of charge, now let me to see the same analysis with charge. Suppose this is your charge, Q, and you are distributing it in more smaller parts. So here the charge of this part is dq, again distributing into more smaller parts. You are again distributing this dq into dq dash. You have more smaller parts. Means q is distributed into dq, dq is distributed into dq dash, and similarly you reach up to smaller and smaller charge. But stop here. Here we cannot enter lower than electron. We have to arrive up to electron. Inside electron there are some elements, that is not elements. Inside electron there are some more fundamental particles which are responsible to construct electron. That particle is quark, something inside the quark. We don't know anything about charge for those particles, and the charges defined there are completely different than these charges. So for this charge, for the electrostatic charge, for the electricity, for the term we use charge, the charge is stopped at electron. Means you have the basic particle electron to charge anything, to put charge anywhere. So you can say that charge is also an intrinsic property, but it begins from electron. Means the packing of charge begins from electron, not smaller than electron. Once we start packing smaller than electron element, we don't define charge. So here, but in terms of mass, that's the main difference between mass and charge. In terms of mass, our packing starts from nowhere. Means you can start from God particle, you can start from boson, you can start from neutrino or anything. Neutrino is considered massless, but inside nucleus, whenever we pack neutrinos, that nucleus has some masses.
Rest mass is zero.
Mass is zero. So there are, means for mass you can begin from nowhere. At the end you have nothing, you have zero. But by compiling to zero, the no masses, you get mass. But in terms of charge, your packing begins from electron. So electron is the smallest element given from nature to pack the charge.
It actually goes to E by 3.
So you can make it Q equals to N. This is one of the main property of electrostatic charge or electric charge, N, where Q is the amount of charge and is the number of electrons required to produce that much charge, is the charge on each electron, where is the charge on electron. Any other value, this is very simple, that is 10 power minus 19 coulomb. It is considered to be negative. Negative doesn't mean any sign convention here. This is just to differentiate the charge of electron to the charge of proton. Because charge on electron is equal in magnitude to the charge on proton, and it is opposite in nature to charge on electron. So the minus is stayed there. Charge on proton is also 1.6 into 10 power minus 19 coulomb. But this time the magnitude are same, but the nature completely different. Not different, sorry, it's opposite. So here minus and here we have to go plus. These plus and minuses have no sign convention. This is just to show the charges of electron and protons are opposite to each other in nature. This. But I don't need to write this here. I have to write only this charge of electron here. So to produce charge, you have to begin with electrons, not smaller than electrons. For electric charge, for electrostatics, for electromagnetism, you begin with electrons, not smaller than electrons. So Q is equals to N. Charge on electron and the number required to produce number of electrons. Q is the amount of charge. What do you notice here? That if I have to produce Q amount of charge, I'll have to find the number N, which is required to produce that much charge, and then I'll have to pack their electrons carrying this number to produce this. Means you have an elementary unit of charge or elementary particle which produces, which gives charge, that is electron. Not smaller than electron for electrostatic case. Yes. And this property of charge means to packing the charge anywhere with the number of electrons is called quantization of charge. This property is called quantization of charge. Quantization. Sorry, it's Z, quantization of charge. Quantization of charge. So by the quantization of charge, I can find that if I need to produce 1 coulomb charge anywhere, then I'll have to pi the n number of electrons, and that number will be 6.25 into 10 power 18 electrons. To produce 1 coulomb of charge, you need to put this much electrons. Listen one thing here, n will be an integral number. So 6.2 pi will be 6, not point. What I say to you, we cannot break electron to pack the charge. Means electron is a basic element to produce charge, to pack charge. So here the fraction gives us 1 by 4 electron, and I said to you earlier that we don't need to break the electron to produce charge, especially in electrostatic case. In that case, so I need 6 into this electron. That is the main difference between these two intrinsic properties of an element or in a matter, that is mass and charge. Now I'm quoting some differences here. This. Listen, one more property, that is the conservation of charge. One more property of charge. That is conservation of charge. There is conservation of mass also, but the conservation of mass has been proven wrong in relativistic case. But in mechanics, you can say the mass is conserved. But in relativistic case, conservation of mass is also invalid. So in electrostatics here also, you can use that conservation of charge is valid. But in relativistic or in quantum electrodynamics or in relativistic case, when we analyze electrostatics or electromagnetism with the help of relativistic case, in quantum electrodynamics, in that case, charge is not conserved. The same thing. So charge is not conserved, and charge and mass is also not conserved in relativistic cases. So now I'm making a chart which analyzes the property of mass and charge, so that you can understand the word charge. Electric charge, mass, C. Intrinsic property. Intrinsic property begins from nowhere. Intrinsic property begins from electrons. Gives us gravitational force Z m1 m2 by r square. Gravitational force. What happens? Bullshit?
Nothing. I'm trying to know that charge conserved at relativistic or
No, charge is also not conserved at relativistic case.
right there.
Q1 Q2 by r square is Coulomb's force. F is equals to Q. F is equals to M. Q is equals to N, conservation of charge. And mass is equals to number of D. Mass is equals to N into number of theoretically, is it visible theoretically?
Yeah, everything is visible. The whole board is visible.
Theoretically is readable or not?
Everything is visible.
See, according to my analysis, I'm not going to teach you, I'm just a student and I'm trying my best to analyze these things. And I'm sharing my own views, whatever I learned from books like Feynman lectures and Griffiths, or some great books, or great physicists, or great scientists. See here, electric charge and electric mass. We have discussed in the beginning of class that these two are the intrinsic property of the same thing. Here, it's also an intrinsic property, it's also an intrinsic property. But what is the difference here? This intrinsic property begins from nowhere. Suppose we have a pack of balls. So mass of one ball into the number of mass into the number of balls gives you the mass of total pack. Suppose come smaller than the ball. You have broken the ball into atoms, molecules. Suppose there is a bunch of molecules. Or you can see mass of each molecule into number of molecules into that pack gives you the mass of the pack. Similarly, the pack of atoms. Mass of each atom into the number of atoms gives you the pack of that, the mass of that pack. More is smaller. While going to nucleus, smaller to the nucleus when proton, neutron, electrons, more smaller quarks. Suppose we have pack of quarks. What happened? Mass of each quark into number of quarks gives you the mass of that pack. Similarly, as small you go, you find the smallest theoretical particle. That is the boson or God particle. It gives mass to everything, which has theoretically the zero mass. So this intrinsic property begins from nowhere, means from where we start our packing. From that point, we are adding masses. So this is intrinsic property begins from nowhere, but intrinsic property begins from electrons. In case of charge, if you have an atom, theoretically that atom is neutral because why? The number of electrons is equals to number of protons inside the nucleus and they cancel each other. The charges of electrons and protons cancel each other. Similarly, come to the molecules. If there are some ions inside the molecules, only then they have charge. Otherwise, they also become neutral because atoms are neutral. So, to produce charge, this is an intrinsic property begins from electrons. Go inside that. Proton, neutron, and nucleus, and electron. Proton is heavier, electron is smallest particle, smallest non-particle yet. So, to produce charge, you put electrons there. Go much deeper into the electron. Break the electrons, break the protons, you have quarks, and the charge of quarks is not related to this property. You cannot assume that this electric charge is related to the charge of quarks. Inside quark, there are many theoretically possible particles that is more and more smaller than electrons. This charge is not defined for them, like mass. So I can say intrinsic property, which is an electric charge is an intrinsic property of any matter, begins from electron, not smaller than electron, like mass. Second thing is, for the mass, F is equals to gm1m2 by r squared, that's the gravitational force. So if anything has mass, whatever be its size, small and high or larger, if anything has mass, there's another mass, they communicate with each other with this force, that is the gravitational force. This force is the gravitational force here, and this force is due to the property, due to this intrinsic property, that is mass. Here, come here, this is also a force, but this force is completely different than this force. F is equals to 1 by 4 pi epsilon on Q and Q2 by r squared. Q1 and Q2 are two separate charges. Two particles which have charges are Q1 and Q2 respectively. They communicate with each other. They have a relation among them based on this force. So this is called electromagnetic force, or especially for this chapter you can tell it Coulomb's force or electrostatic force. This force is completely different in this force. So you cannot say that this force is produced by mass. This force is produced by charge. So intrinsic property is responsible for electrostatic force. It is two particles, two matters, two bodies, that is the electrostatic force, and that intrinsic property which is responsible for this force is electric charge. The third analysis, F equals to ma. If we have a mass and it is under the influence of gravitational force, then that mass takes some of the acceleration. That acceleration determines the direction of force. This acceleration is always in the direction of the force, this gravitational force. Here, this intrinsic property is the charge. And if it is under the influence of electrostatic force, it will also experience something like acceleration in mechanics. Acceleration for mass, E plays the same role for the charge. It also gives you the direction of the force applied on charge. But there is some difference in Q to M. What is the main difference that we notice while studying the next topic, that is the Coulomb's force? F equals to QE, F equals to MA. A decides the direction of F, not decides. Or you can say that F is along the direction of A, but here F may be along the direction of E or may not. That's the main difference between M and Q. So you cannot say that these two intrinsic properties are likely to each other. They have some basic differences too. And the last thing, Q, here M equals to number. If I have a pack of mass, I have already discussed the segment here. If I have a pack of mass M, then I'll have to identify what is the smallest theoretical particle in that pack. And I'll have to find the mass. Sorry, I have written something wrong here. Actually, this is not number, but this is a mass. If I have a pack, then I'll have to find the smallest theoretically possible particle inside that pack and find the mass of that particle, theoretically smallest particle inside that pack, and count its number. It gives me the product of these two things, gives me the mass of that pack. This is just as the quantization of mass there also. Come here. If I need to pack a charge, then I'll have to search only the number of electrons inside that pack, not smaller than an electron. Here, the sequence goes on to up to nowhere, but here sequence stops at electrons. Means I can only arrange charge with electrons at the smallest level. Understood? Quite clear that the charge is also an intrinsic property of any elemental matter, but with just some basic differences. It gives you feeling like mass, but it is not mass. It has some basic differences also and some similarities also. So in one line you can make a definition that the charge is an intrinsic property of an element or matter or any particle which is responsible for electrostatic force. That force is completely different to the gravitational force. I'm going to write this.
Share of it.
How long? What's the total time period?
37.70.
Waiting 5 or 10 minutes more. Impossible to stop it now. Stop it.